All right, if you're a Salesforce developer, you know exactly what I'm talking about. That feeling when your code works perfectly, and then suddenly, it just doesn't. Today, we're going to demystify one of the most famous, or maybe infamous, errors in the Salesforce world. This is the big question, right? You test your code, it works like a charm. You run it 5 minutes later with the exact same data, and boom, it fails. So what gives? What's really going on? Well, it usually comes down to this one very familiar message. Ah, yes, our old friend, the Apex CPU time limit exceeded error. It's basically Salesforce telling you, hey, your code took too long to think. But the real mystery, the part that makes you want to pull your hair out, is how unpredictable it is. Okay, let's really get into this. We're about to solve the mystery of what's called non-determinism. It's a fancy term, but it's the simple reason why your code can pass a test at 9 o'clock and then fail that same exact test 5 minutes later. And spoiler alert, it's probably not your fault and it's definitely not random. There are real reasons this happens.
Now, getting your head around this is super important. Non-determinism just means that in a huge shared system like the Salesforce platform, little variations are going to happen. It's not a bug, it's more like a law of physics for the cloud.
So, what are these sneaky little variations? Let's pull back the curtain and find out. We're going to unmask the hidden forces, the culprits that are working behind the scenes, nudging your code's performance just enough to push it over that limit. And here's the crazy part. Look at this list. You don't directly control any of this. The overall traffic on the platform, the first time your code gets compiled, when the system decides to do a little memory cleanup. These are all background processes that can cause tiny changes in how fast your code runs. This is honestly the best way to think about it. You're not in your own private house. You're in a massive apartment building with thousands of other people. And if your upstairs neighbor decides to run their dishwasher, their washing machine, and take a long shower all at once, you might notice your water pressure drop just a little bit. It's the same idea on the platform.
Okay, let's tackle JIT, which stands for Just-in-Time Compilation. Imagine you ask a professional translator to read a complicated book out loud. The very first time they have to read the words, process them, and translate on the fly. It's going to be a bit slower. But the second time they read it, they remember it all, and it's way faster. That first run includes the translation cost. Every run after that uses the already translated, ready-to-go version.
And then you've got garbage collection. This is basically the system's automatic cleanup crew. It comes through and tidies up memory that your code isn't using anymore. It's super important, but you never know exactly when that cleanup crew is going to sweep through your area, and that sweeping takes up a tiny bit of time. Okay, so now we get the why. We can't stop our neighbor from taking a long shower, right? But that doesn't mean we're powerless. This is where we shift our mindset. We stop being reactive and fixing the error after it happens, and we start being proactive by building what I like to call a resilience playbook.
So here it is, our game plan. 4 simple pillars to build truly resilient code. This is your guide to writing Apex that doesn't just work, but can handle anything the platform throws at it. Let's make our code bulletproof.
First things first, let's talk about your fundamental defenses. Think of this as your first line of protection, the non-negotiable stuff that should be in every single line of Apex you write to guard against that CPU error. This right here, this is the golden rule, the most important takeaway from this whole thing. You cannot aim to be just under the limit. If your code consistently takes 9.5 seconds to run, it's a ticking time bomb. You have to build in a safety margin, a buffer, for all those little platform fluctuations we just talked about. So what's a safe number? What should you be aiming for? A good rule of thumb is to shoot for using only 50 to 70% of the available time. Think about it. If your code is built to run in 7 seconds, a half-second hiccup from the platform is no big deal. But if you're running at 9.9 seconds, that same hiccup is a fatal error. And how do you create that buffer? By being aggressive with your optimization. This list should be second nature to you. It's Apex 101, but it's absolutely crucial. Never, ever put a query or DML inside a loop. Use maps to handle data efficiently. Write smart, selective queries. These are not suggestions, my friends. These are the requirements for writing professional, resilient code.
Okay, but what happens when you've done all that, and your super complex process is still breathing down the neck of that CPU limit? Well, that's when we pull out the big guns. Let's get into some advanced strategies for when the basics just aren't cutting it.
I mean, just look at this. This slide says it all.
The power of going asynchronous is just wow. Instead of one giant process that has 10 seconds to finish, you can break it up into smaller asynchronous chunks. And each one gets a whopping 60 seconds. That's a 6x increase. This is the ultimate escape hatch for heavy-duty jobs.
And you've got a couple of other powerful tools in your toolbox for that really heavy lifting. If you're doing the same expensive math over and over again, don't. Do it once and store the answer in platform cache. And for the absolute toughest problems, hey, maybe Apex isn't the right tool. You can offload the work to an outside service like Heroku or AWS and just have Salesforce call it. All right, our last pillar, and this is so critical for getting better over time. You have to stop guessing. You can't just look at your code and think, maybe that loop is slow. You have to measure it with precision.
And the good news is, Salesforce doesn't leave you in the dark. You've got a whole toolkit right here. Dive into your logs, use the Apex Profiler to see exactly which line of code is eating up all your time, and use event monitoring to keep an eye on performance out in the real world. You know, at the end of the day, it all comes down to this simple idea. This is the mindset you want to have. Don't ask, how can I barely sneak under the limit? Ask, how can I design my code so well that I don't even have to think about the limit? That's when you've really won. So I'm going to leave you with this one question to think about next time you're coding. Is the code you're writing just functional? Does it just get the job done for now? Or is it truly resilient? Is it built to withstand all those hidden forces we talked about and to stand the test of time? That's the difference between good code and great code.